When a client makes a request to a server, also keep in mind that a client doesn't have to be a front end necessarily. It could be a back end or a microservice calling another one. We expect a response from that server, whether a successful one or an error. But in both cases, we did receive a response from the server. Now, what if we do not receive anything, whether because the server is down or because we have a network issue? Well, the client is going to be waiting and hanging forever because it expects something to know what to do. So what now? Well, timeout is here to save the day. Timeout is the max wait time for a specific request. It's used so that our application is not going to be hanging forever and waiting forever when there's no response or error being returned from the server. So that way, we wait a specific amount of time for an API or a server to respond, and if it does not respond within that specific time, we do something else. In JavaScript, we can use the built-in function Promise.race to handle timeouts. Promise.race takes an array of promises and returns the result of the first promise or the quickest promise to either resolve or reject. So let's say here we have a race between P1 and P2, and P2 resolved at T1, so it was quicker than P1, which rejected at T2. Then the result of Promise.race was resolved because P2 was quicker than P1 and P2 resolved. But let's say, for example, that P1 rejected at T1, so it was quicker and it happened before P2 resolving at T2, then Promise.race rejected as well, since it took the result of the quickest promise to either reject or resolve. Now let's see that in a more concrete example in our code. So here we have a function, request with timeout, in which we are going to use Promise.race, and like we said previously, we need to pass in an array of promises, and just a reminder, the result of Promise.race is going to be the result of the first or the quickest promise to either resolve or reject. And if we hover the mouse over race, we can see it creates a promise that is resolved or rejected when any of the provided promises are resolved or rejected. I'm also using await with async, but of course you could have used .then block, but I'd much rather use async with await whenever I can. And now let's take a look at the promises in that array. First, we have here a fake API call, and to simulate it, I'm using set timeout, and I'm setting it to 10 seconds. So the API call is going to return a value after 10 seconds, which is a long time. It's going to resolve API response. Here, of course, in typical applications, we're normally going to have a JSON object being returned. And the second promise, we have a timeout function. We are using set timeout, and we are setting the timeout to 5 seconds, which means that if 5 seconds are passed, we're going to reject and throw an error of request timeout. Of course, here we have a try-catch block. If the response or if Promise.race returned a result, if it resolved, we're going to get a response and we're going to log it. However, if an error was thrown, we are going to catch it, and then we are going to print the error message. It's obvious in this example that the timeout function is going to be executed before the API function because 5 seconds, of course, is quicker than 10 seconds. So the value returned by Promise.race is going to be the value of timeout, which in this case, it rejected, it did not resolve. So it should be normally, in theory, caught here. Let's see that if it's going to work like that. As you can see, after 5 seconds, we caught an error here, caught error with error message, request timeout, which is the error message that we threw here. Now let's say our API call only took 1 second. Let's run that again. If you take a look in the console again, as you can see, this time we did not go to the catch block. Instead, we received a response here and we logged it, which was the result is API response, which is the value resolved here. Usually, the time set before throwing a timeout is placed in a configuration file. It could be between 10 to 30 seconds. You choose how long you want to wait. Of course, if you've used mobile applications before, you know that a loading screen isn't always running. It might run for 10 seconds and then it gives you a button asking you to press it to try again. So it doesn't get stuck in an infinite loop. And that's the normal behavior. You should never wait for an API forever. What if the server does not respond? You can't just keep your application hanging there. You should always handle it by using a timeout function, just like we did in that example. Now, our code isn't perfect yet. There's something missing that you can't see. So I'm gonna show you what the problem is and we're gonna fix it. Let's say our API takes 2 seconds and our timeout function is set to 7 seconds. Of course, like we've seen before, the promise.race is gonna return the result, it's gonna resolve because 2 seconds is faster. The API or the request did indeed respond, it did send us a response. So the timeout function is going to be the last in this race. It's not going to be taken into consideration when getting the result of promise.race. However, let's say we have a log here just to show you what's happening in the background. And now let's run our code. Obviously, we're going to get the response here after 2 seconds, just like it happened here. And I forgot to save, so let's save again. As you can see, after 2 seconds, we did get the response, but we still got inside timeout, which is this, which means that although we did get the correct response here, and we did not throw a timeout error, since we did receive a response within the 7 seconds, we still we still executed the code inside of the timeout function here. And that's not what we want. Because in this case, as we've seen now, even though we did get the response here, our timeout function was still running in the background. It didn't stop, and that's wrong. We're using memory for nothing. We're using our CPU for nothing. So we need to stop this timeout as soon as here we're done with it. As soon as we get a response here. And for that, let's go ahead and create a variable and call it timeout handler. And then here, this timeout function here is going to be our timeout handler. So timeout handler equal this timeout function right here. And now in our code here, we need to say that whenever we get a response, this timeout handler should be cleared. It should be reset. So here we can say clear timeout, and we need to pass in the timeout, which is timeout handler. And now if you go ahead and save and run the code again, as you can see, we received the response from our API and the code stopped executing here and it did not continue. So it just cleared this timeout right here. So we're not doing work in the background that we're not supposed to be doing anymore. And now this is perfect. Now let's move to a more complicated problem. So I have here two Node.js applications. The first one is called client and the second one is called server. And keep in mind that both of them have APIs, so they have routes, and it's like different microservices communicating with each other. And we have Postman, our main client, that is going to send the request. Now in the client app, I have one route. I'm using Express, by the way, and I have one API which is of type GET, and the route is /clients. And if you take a look at the left side here, I have a client service, which is a class that has a method called getAllClients, and we're going to use Axios to make an API call to the server to get clients. So we have two servers here. The first one, which is this one, which is the client that Postman communicates with, and then we have like a third party or a second server that has clients stored there. That is the second application. Let's go back to the first application and take a look at our timeout.service.js. Here, you've already seen this code before in our first example. We have the timeout function that is going to reject after a certain amount of time, which is 5 seconds here. And we have our request with timeout function that is going to contain the promise.race method that is going to have a race between the timeout function here and whatever function we pass in here as a parameter, which is going to be our API call. And then, like we said before, we need to clear the timeout so that there's no tasks going on in the background. And since Axios returns the data with a field called data, then we're going to return the data like that. And if you catch an error, we are going to throw it. And in our app.js here, we are going to catch it and then return it as JSON to Postman. Now, if you take a look here in our clients, in our app.get clients API, we are passing client service.get all clients. So this method is being passed to the request with timeout function. So this is the argument. This is the promise that we're going to send that is going to be in a race with the timeout function. It'll be confusing, so let's take it step by step. When a user calls this route, makes a request to this route, okay? So this API, when it's invoked, we're going to call the request with timeout function, and we're going to pass in the get all clients promise as a promise. So here we have the timeout function, and we have the API call parameter, which is in our case the get all clients function, which is this one here, which is going to make an API call itself to our server, which is this one here. Of course, our server has this API get method, and the route is /get clients, which we are calling here. Of course, we need to set the domain name, which is localhost, since it's on my local machine, and the port is 3001 because that's the port that the server is listening to in our server application. Now here I'm returning the clients right away. I'm doing response.send and I'm returning this array of clients. So of course, this is going to get a result in a few milliseconds, so it's not going to take time. And our timeout function waits 5 seconds before returning an error. So of course, this Axios call, this API call is going to return a response way faster than the time needed to execute the rejection here. So of course, it's not going to reject, it's going to send a response. And let's see that in action. I'm running both servers, so now in Postman, let's press on send. And as you can see here, we indeed received a response. Now let's say our server takes time. So instead of returning the response right away, it's doing some actions here, maybe fetching the data from a database or so on, and it takes up to 6 seconds. Now if we go back to our client application and request with timeout, our timeout function waits for 5 seconds only. So it's going to take longer here to fetch the data, longer than our timeout time. I'm going to make a new API call now, but this time with a timeout on the server app, and let's see what happens. As you can see, it's taking a while, and then we return an error, request timeout. And that's because our timeout function won the race between the timeout and the API call, which is again the Axios call that we are making here. And that's because on our server, it took a long time to return the results. This is just a quick example just to show you how it can be done in real life. It's more realistic that way. Maybe it will help you more in your cases. Now, luckily, you don't always have to do all of that from scratch like we've done, although it's important to know that, because in some cases you might not be using something like Axios. You might be using Kafka or something else, or listening in a different way for a response. So you could use Promise.race and pass in the timeout and the other promise. But in our case, luckily, Axios already has a parameter called timeout. So for example, let's set the timeout to 2, which means 2 seconds. Let's run again. And now if in Postman we press on send, as you can see, we got timeout of 2 milliseconds exceeded. By the way, yeah, that's not 2 seconds, that's 2 milliseconds, my bad. If you want 2 seconds, we would need to add this. And now if we press on send, timeout of 2000 milliseconds exceeded. And of course, if our server here doesn't have to wait for 6 seconds, it's not doing that much of a job. It returns right away. It's going to be quicker than 2 seconds. So here again, we're going to receive the response. Now, if you're using Axios, luckily you can just use that right away. You don't have to do things from scratch. You don't have to use Promise.race. However, It's important that you know the existence of Promise.race or the use cases, because in some cases you're not going to be using Axios, yet you're going to be waiting for a response from a different server, maybe through a message broker or some other packages other than Axios that doesn't have the parameter timeout. Then you would need to do something like that. And that was the purpose of this video. If it helped you at all, please leave a like, subscribe. If you have feedback of how I can improve my videos, please let me know in the comment section, or if you have any video idea for the future. Thank you and see you next time.